Alright, hello everyone. So welcome back to another video. So far in this partial fraction decomposition video series, we learn how to do a basic decomposition, right? But we have to finish the partial fraction decomposition process. To finish that, we have to evaluate the constants. That means like A, B, C, all those constants that you have in the decomposition, you have to find them, okay? You have to find their values. So how do you do that? To do that, we have couple of methods, okay? So you can use both these methods. So what I'm going to do is I'm going to touch on method 1 in this video. I'm going to do method 2 in another video. The thing is that this method, like method 1, works best for certain types of problems, but it does not work well, for example, like with a problem with irreducible factors. But for a problem with irreducible factors, method 2 would works best, but method 2 would not works best for problems like these types. Okay, I mean, so let's distinguish these two methods depends on the type of the problems that we have. All right, so first method, what should you do? So in this video, I'm going to talk about problems with the distinct linear factors and linear repeated factors. So if you have such a problem, method 1 works the best. Okay, perfect. So what I'm going to do is, so here's the problem that is given to me. I have done the decomposition for you already. What I'm going to do is I'm going to write the denominator of that big fraction using the factors. I mean, you do that already, right? That was your first step, just to factor the denominator, right? It's just I didn't write that out here. So write it down here and let's write the decomposition. Now what you're going to do to find these constants is that you take this denominator, factor denominator of that big rational function, and multiply every term on the both left hand side and the right hand side by that big denominator. Okay, so let me show you. So I'm going to take that big denominator, x minus 3x plus 2, and multiply everything on the both sides of this big expression by that denominator. So you have a of x minus 3 multiplied by x minus 3 x plus 2. So I'm going to multiply each term, okay? Plus b over x plus 2 x minus 3 times x plus 2. Okay, this is the way I like to think about it. Okay, so there are a couple of ways you can think about it. I'll show you it later, but can you understand what I'm doing here? So I took that big factor denominator, multiply each term. That's crucial. Every term in both left hand side and the right hand side, okay, in both sides by that denominator. Perfect. Now see what's going on here. So actually in the left hand side, everything cancel out, right? That denominator, because you multiply by that denominator itself, so it cancel out. So what we get is here x plus 1 equal to, now actually you can think this multiplication, the thing that I did here, as like taking this big denominator and like taking it into the right hand side, like switching it into the right hand side. When you switch a denominator on the left hand side to the right hand side, it goes to the numerator, right? Like you have to multiply each term here by that denominator, right? So that's what's going on, but I would like to think it in this way so that hopefully it's clear for you guys. Okay, so many ways you can think about it. Just pick up the one that's making more sense for you. Okay, all right, so let's cancel out. So x minus 3 cancel out, see, and here x plus 2 cancel out. So what's left is a times x plus 2 plus b times x minus 3. So basically what I did here is I got rid of denominators. Can you see? There's no fractions here, just simple terms. That's the purpose, okay, of that multiplying by that denominator. Think about it, like take time to think about this. What's going on here? I mean, what we did actually makes sense if we want to get rid of the denominator, because I mean, once you multiply by this whole thing, the left hand side denominator goes away, and of course in the right hand side x minus 3 cancel out, so the factor corresponding to x minus 3 cancel out and the other factor remained here, right? And x plus 2 cancelled out and x minus 3 remained here. So look at this expression. you go. Think about that for several minutes, okay? All right. So now what you're going to do here is that you're going to use magic numbers. Okay, so yes, I would like to call them magic numbers. So I want to find A and B. So the beauty of method 1 is, let's try to find A. Now to find A, I'm going to substitute certain values for X. Okay, replace X by certain numbers. But these numbers are magical. I'm going to substitute 3 for X. Guess what happens? So 3 for X, so here 3 plus 1. A, 3 plus 2. Guess what's happened here? What is 3 minus 3? 0. So B times 0 is 0. So 3 is a magic number that get rid of B, and here it's 4. Here 3 plus 2 is 5. So 4 is equal to 5A. Guess what is A? 4 over 5. So what this magic numbers does is that it get rid of other constants and just give you the constant that you want to find, A. Now if you want to find B, what is the magic number? Now tell me, what's the number that you would plug for X? Minus 2. See what happens when you substitute minus 2. So minus 2 plus 1 on the left. A times minus 2 plus 2, because it will make this term 0, right? B minus 2 minus 3. So negative 2 plus 1 is negative 1. Here 0, right? Negative 2 minus negative 3 is negative 5B. So what is B? Negative cancel out, 1 over 5. Okay, so negative 2 is the other magic number. So 3 and negative 2, exactly the numbers that makes these factors 0. So you would choose each magic number at a time and plug them in, and you will be able to find the constants. That's method 1. Okay, all right, so let's finish the problem by again rewriting the decomposition, because now we know A and B. So A is 4 over 5, so 4 over 5 x minus 3 plus what is B? 1 over 5. Come on, 1 over 5 x plus 2. This is the complete partial fraction decomposition of this fraction, okay, using method 1. All right, so I'm not going to leave you here. I'm going to do more problems. Okay, so the good thing to do is pause this video and try to do the problem by yourself, and make sure you get the same answers as me. So here's another problem. The decomposition is already done for you. You just need to find A and B. Now let me do this fast, hopefully because you understand the process. All right, okay, don't skip out of the video right now, because the third example is special, so be with me. All right, so here's what I'm going to do. What I'm going to do here, multiply everything by this big denominator, right? So on the left hand side, I will left it minus 8x minus 20, right? Now you don't have to show that step. If you understand it, guess what you're going to have here? A times what? X plus 3, right? Because x plus 1, 7 factor will cancel out. You will left it x plus 3. Here what you are going to left it? X plus 7, right? Because x plus 3 cancel out. So you would be able to do that in your mind very fast, okay, once you understand it. That is why I told you, take several minutes or seconds and understand that step clearly, the purpose of it as well. All right, now magic numbers. If you want to find A, what is the magic number? If you want to find A, choose X to be negative 7. Get rid of B. Okay, so let's substitute negative 7. So negative 8 times negative 7 minus 20. A times negative 7 plus 3, what is it? Negative 4. Yes, this part is 0, right? Because negative 7 plus 7 is 0. So that's good. Okay. Negative 8 times negative 7 is plus 56. 56 minus 20 is, let's see, 36. 36 minus 4A. So guess what? What is A? 36 divided by negative 4, negative 9. A is negative 9. See how easy it is? All right. Then let's find B. To find B, what is the X value that you should substitute? Magic number is, get rid of A, use negative 3. So if X is negative 3, negative 8 times negative 3 is 24. 24 minus 20 is 4. On the left, I did that fast. Negative 3 plus negative 3 plus 3 is 0. Sorry about that. So B times negative 3 plus 7 is 4, right? Oh, B is 1. 4 over 4 is 1. Oh, good numbers. Okay. So A is negative 9, B is 1. So let's substitute them back. A is negative 9, so negative 9, B is 1. This is your complete decomposition. See how easy it is? Okay, understand method 1. Alright. Okay, last problem that I'm gonna do in this video. Now all those cases were distinct linear factors. How about if we have repeated factors? Let me show you the problem. 1 over x plus 7 x plus 2 square. Okay, so the decomposition is a over x plus 2 plus b over x plus 2 square, right, because x plus 2 is repeated twice, plus c over x plus 7. So this is the decomposition. Let's find a, b and c. What do? Multiply by the denominator. So the left hand side is 1, right, because the big denominator here is x plus 7 times x plus 2 square. Okay, understand that. So if you multiply a over x plus 2, okay, I'll show you, okay, because this is very important here. So I will multiply by x plus 7, x plus 2 square, b, x plus 2 square, x plus 7, x plus 2 square, plus c over x plus 7 multiplied by x plus 7, x plus 2 square, right? Okay. Alright, so what do you get? A, 1 on the left, a over x plus 2, not over, x plus 2 cancel out, but just a 1 x plus 2, okay? So another x plus 2 will remain because it was x plus 2 square. Here b, now x plus 2 square cancel out, so it's going to be b times x plus 7. Plus c, x plus 7 cancel out, but you are left with x plus 2 square. Okay, so that's the difference with repeated factors. So be careful a little bit. All right, now the magic numbers. Here's where it gets tricky. Okay, let's use black color. Now let's say you want to find c. What magic number you can use? If we choose x to be negative 7, think about this. If x is negative 7, this term will cancel out because negative 7 plus 7 is 0. This term will cancel out and we will remain with term c and we can find c. So left hand side it's just 1, right? There's no x. And c times negative 7 plus 2 is what? Negative 5. Negative 5 square is 25. So c is 1 over 25. Okay, so we found c. Alright. Now, what is the other magic number? Well, you can use negative 2, not t, negative 2. So if you use negative 2, left hand side will be 1. Here this will be 0, right? Negative 2 plus negative 2 is 0. So b times negative 2 plus 7 is what? 5. Plus this term will also cancel out, right? Negative 2 plus 2 is 0. So 0 square is 0. So that's gone. So b is 1 over 5. So that was also normal. Okay, so you don't have to find A, B, C in order. Okay, you can find C, B, C. First find phi B, first find C. Doesn't matter. Right, now here's the tricky part. What is the magic number that we should use to find A? What do you think? Is there another magic number that will cancel B term and C term both but left it only A? Is that possible? No, right? There's no other magic number. There's only 2 factors and 2 magic numbers. You can't use negative 2 or negative 7 to find A. What can we do now here? We are stuck. Guess what? You know already B and C. You just need to find A. Choose any number you like other than negative 2 or negative 7 and substitute. Okay, so let me show you. Let's choose like what? What is the easiest number we can choose for x? 0. Okay, choose any number you like. You can use 10 if you like, but the computations will be, now the numbers will be big, but you will get the same answer. But 0 is the easiest answer, so let's use easiest number, so let's use 0. So if x is 0, this will be A times 0 plus 7 is 7, 0 plus 2 is 2. B is now, we already know B, okay, so we can use that advantage. B is 1 over 5 times 0 plus 7 is 7, plus C is 1 over 25, 0 plus 2 is 2, 2 square is 4. See? Okay, so you can choose any number you like. See, the only constant you need to find here is A, so you can simplify this and find A. So that's the secret. So 7 times 2, it's 14A. So plus this is 7 over 5, this is 4 over 25. Let's make the common denominator here to add those fractions, so let's multiply both side, numerator and denominator, by 5. So it's 114a, so 7 times 5 is 35, 35 over 25 plus 4 over 25, which is 114a, 39, not plus 39 over 25. So take this to the right, left hand side. Okay, take this term to the left hand side. So 1 minus 39 over 25 is 14a. So this will be 25 minus 39 if we simplify the fractions. I will do that fast. Okay, so this is what? 25 minus 39 is negative 14 over 25 is equal to 14a. So a is negative 1 over 25. Alright, so isn't that easy? A is negative 25. So we have all the numbers, all the constants. Okay, so let's finish the decomposition. Here was our problem. Oh, A is negative 1 over 25. What was B? B is 1 over 5. So we can replace it here, 1 over 5. C is 1 over 25. There we go. This is the decomposition. Okay, replace those numbers and rewrite it. That's the final step. Okay, so what is the new trick that we learn in this newest problem? Well, use the magic numbers. Once you ran out of magic numbers, use any number you like. Okay, but just use the simplest number you can find. You could have used 1 here also. That would have made your life easy too. Okay, but 0 just work well as well. So that's how you find the constants A and all those constants in decomposition with method 1. Remember, we can use method 1 for distinct linear factors or problems with linear repeated factors like this. Okay, so for irreducible factors, I'll catch you in the next video and I will teach you method 2. Okay, all right, bye bye. Thank you very much.